Because I didn't have time in class to go over the quiz on Edpuzzle, over the electrolysis lecture in Chapter 18, I thought I'd spend a few minutes here explaining the answers to the quiz questions. So this first question, what is the sign of delta G for an electrolysis reaction? That's simply realizing that electrolysis reaction is, by definition, a non-spontaneous electrochemical reaction. And of course, non-spontaneous means delta G, or free energy, has a positive sign. Okay. This question is comparing galvanic cells to electrolytic cells. Galvanic cells, also called voltaic cells, are spontaneous cells. So it's comparing the voltaic cell to the electrolytic cell, which are non-spontaneous. And the correct answer is this first one. A voltaic cell contains two half cells. They have to be separated. So you have to have the anode and the cathode and connected by a wire for the electrons to transfer, and also by a salt bridge to equalize the charge with ions. And an electrolytic cell is all in the same container, and that's because it sometimes has like a semi-permeable membrane, but it's because the substances that are oxidized and reduced in an electrolytic cell all come from the same substance, and it's typically an ionic compound, a salt. And what happens is that salt, the cation, becomes reduced and makes the neutral metal, and that's used for electroplating when you spray metal coating on things. And the anion from the salt gets oxidized to make the neutral nonmetal, in this case chlorine gas, which is typically not the product that is needed or used, but it's a byproduct. The rest of them, it's also helpful to note, are the same for both. So oxidation occurs at the anode and reduction occurs at the cathode for both types of cells. So our little mnemonic, an ox chased a red cat, works for both types of cells. Electrical current causes a non-spontaneous reaction to occur. That is describing only the electrolytic cell. Electrons originate at the anode only describes a voltaic cell. Where do the electrons originate in an electrolytic cell? They originate from a power source, okay, a battery or something. Okay, so electrons are from the power source. And electrons flow from the anode to the cathode, A before C, which is true of both types of cells. This is a fundamental question about electrolytic cells that you need to understand. And I would say if you don't take the time to understand anything else about an electrolytic cell, this would be the one that I would start with. Because you will always be given an ionic compound. In this case, they're talking about aluminum bromide. And it has to be either molten, which means melted, or an aqueous solution. But in any case, the first thing to do, I think, so that you can visualize the problem better, is to separate the salt into its cation and its anions. And then this is what you need to understand. The cation in an electrolytic cell, of course, will accept electrons, which means it will be reduced to the neutral metal. And this is why electrolysis is so useful, is getting that neutral metal. Then the anion in the salt will give up these extra electrons it has to make the neutral nonmetal. Okay? So let's look at the possible choices. The cation has been reduced to form the neutral metal, so reduction occurs at the cathode, red cat. So at the cathode, aluminum is formed. So let's find that choice. So this first one at the cathode, aluminum, that is correct. We can cross this one out, and this one out, and this one out. Just to double check ourselves that we didn't make a silly mistake, is bromine formed at the anode? Well, at the anode is oxidation, which means losing electrons, and this bromine anion does in fact lose electrons to make the nitrobromine molecule. So yes, this is the correct answer choice. There is a slide in my PowerPoint and lecture over electrolysis that talks about the electrolysis of water. And so the next step in understanding electrolytic cells is to understand that the role that water plays. I told you that if you have a salt or an ionic compound, you can either electrolyze it in the molten or melted state, or you can dissolve it in water. If you have an aqueous solution of a salt, okay, the complicating factor is that water itself can be electrolyzed. Okay, so the overall reaction for water getting electrolyzed, so we'll put electricity here. If you drop a battery in water, you can see evidence of this happening, is you are going to make some hydrogen gas and some oxygen gas. Okay, so these are both gas, liquid, and I suppose I should balance it. There we go. All right, so this is the overall reaction. This question is asking you what happens at the anode. So this electrolytic reaction for water can be broken into two half reactions, just like every electrochemical reaction can be. There's always one reaction that occurs at the anode and one at the cathode. So the anode, we know oxidation is occurring. So something is losing electrons. So we have to find out which of the atoms in water is losing electrons. You can either look at the two half reactions for water that are in the standard reduction table and find which one is oxidation, which one is reduction, or you can figure it out as always by assigning oxidation numbers. So I'm going to assign oxidation numbers. I'm going to give oxygen a -2 as always, and each hydrogen atom has a +1. On the product side, of course, neutral elements in their standard state have oxidation numbers of 0. And so let's see, what has been oxidized in this electrolysis of water? The thing that has lost electrons has been the oxygen atom. It's gone from a -2 as part of water to a 0. It's given up there. Okay, so it has lost electrons. So the oxygen atom has been oxidized. And in turn, the hydrogen atom, which had a +1, the hydrogen atom in water, on the reactant side, goes on to have an oxidation state of 0 on the product side, and so it has gained electrons and been reduced. So looking at the answer choices, you can cross the first one out. The first one is the overall balanced reaction for both oxidation and reduction. Remember what we said is oxidized is the oxygen atom. So the half reaction that shows that is right here. That is the correct answer. What is this last choice showing? It is showing reduction of the hydrogen. The OHs and H+ are just side products. All right, so there is a rule in pretty much all electrochemical reactions, including electrolysis, that the more positive the reduction potential, the more likely that substance will be reduced. Because remember, positive is good in electrochemical reactions. All right, so let's look at all of them. Which one is the most positive reduction potential? First, make sure that they are written as reductions, just in case there's a trick question, which I will never deliberately do, but no claims for the final. So they all are written as reductions, which any standard reduction table should do. And so I'm looking for the most positive value, which is the reduction of the nickel cation. So that is the correct answer. Don't get distracted by water. It doesn't say aqueous, it says molten. That means no water, that simply means melted. So don't even bother to look the water value up. So now we consider an aqueous solution. Okay, so let's write out aluminum fluoride. Remember, the aluminum always, as an ion, always has a +3 charge, so it's AlF3. It is aqueous, okay? So not only do we have to consider the oxidation and reduction of the cation and anion, we also have to consider the oxidation and the reduction of water. So we know that if the aluminum cation gets reduced, it will make aluminum metal. So we need to look up the voltage required for that. We know that if fluoride is oxidized, it will make fluorine gas. Okay, so again, we need to look up the voltage for oxidizing fluoride anion. Now, if water gets oxidized or reduced, these are the products and the voltages. And you find that from looking at the standard reduction table. I strongly recommend that you take a minute right now, look at a standard reduction table. It can be in the appendix of your book. It could be one that I put on the in-class worksheets in D2L, or you can just Google one. But it can be tricky finding the standard oxidation and reduction potentials of water. There are two half reactions shown in the standard reduction table, of course both written as reductions, so you have to find which one is truly representative of reduction and one is representative of oxidation. So when you're looking at the standard reduction table, which I hope you're doing now, one of the half reactions you will find is 2 water molecules plus 2 electrons goes to hydrogen gas and 2 hydroxides. That is clearly a reduction half reaction because it's adding electrons. And the voltage for that is minus 0.83 volts. All right, that's reduction. There's another half reaction. Let me find it for just a minute where to go. Okay, and it's backwards. It shows water as a product. So let me write out the way that it's shown in the standard reduction table. Oops, wait. 4 electrons. Okay, 2H2O. Okay, that is written as a reduction reaction, as everything is in the table. However, we are not starting with oxygen. So this is obviously the one that needs to be flipped to see what happens on the oxidation half reaction of water. Flip that one so that water is your reactant, and that's what we're starting with. And so therefore our oxidation half reaction for water is this, and its voltage, remember to also flip the voltage, is minus 1.23 volts. So you can see why electrolyzing water is not spontaneous. You have to put energy in, because the total voltage for electrolyzing water, it would be minus 0.83 minus 1.23. It takes quite a bit of energy. And so now we need to compare the two things that can be reduced, which are the aluminum cation, to water. This is the reduction half reaction for water. We're comparing these two, okay? So which one of these has the more positive or is the easiest to reduce? So the voltage of reducing aluminum ion to aluminum metal is, and I've got the standard reduction table right in front of me. There's aluminum. Okay, so that is minus 1.66 volts, okay, versus minus 0.83 volts for water. So what's going to happen is the aluminum cation will not get reduced. The water will be preferentially reduced because it requires less energy, okay? So aluminum cannot be produced at one electrode. So those two go out because we know that hydrogen gas and hydroxide will be produced at one of the electrodes. That information alone tells you that the correct answer is here. But I'm going to go through the other rationale just because you need to be able to do that. So now let's look at the substances that can be oxidized in this electrolytic cell. The fluoride anion could be oxidized, and the reduction potential for that, it's positive 2.87 in the reduction table, so we have to flip that because it's being oxidized. So minus 2.87 volts. Okay. Now look over at water being oxidized. It's right here. So we are comparing these two half reactions. So water being oxidized is minus 1.23 volts. Fluoride being oxidized is minus 2.87 volts. And so once again, fluoride is not going to be touched and water is going to be oxidized. So we found that it's not a good idea if you want to electrolyze aluminum fluoride. It's not a good idea to put it in water because water will be preferentially oxidized and reduced. That's that answer. Last question. These types of questions, and I will give you a hint now if you're listening to this, give you a little reward. There will be a question like this on your exam. So you do need to be able to do this. This is just a big unit cancellation question. And so the most important thing I think you need to know is that an amp, which is abbreviated capital A, is equal to coulombs per second. The abbreviation for coulombs is typically a capital C. So it's not as important where you start as long as you set up your unit cancellation. So I usually start with amps. So I'm going to start with the 3.6 amps, and I know that means it's 3.6 coulombs per second. Okay? Then typically the problem will give you time. So I try to cancel out seconds first. So I know that there are 60 seconds in 1 minute. Okay, my seconds cancel. And I know I'm going to do it for 14 minutes. So I usually kind of break it into two calculations. You don't need to. But if you plug all this into your calculator, 3.6 times 60 times 14, you get, that is 3,024. And the units I have are coulombs. And then I usually kind of treat it as a second calculation. So if I have 3,024 coulombs, how do I get to mass of nickel? That's where Faraday's constant comes into play. So Faraday's constant shows up in a couple of equations, but it's represented with a capital F, and it's about 96,500 coulombs per mole of electrons, right? 96,500 coulombs per 1 mole of electrons. And at this point you need to know the mole ratio between the moles of electrons And so at this point, you need to have the half reaction balanced. And that's very simple. You just have nickel, it has a +2 charge. And how many electrons do you have to add to make neutral nickel? You have to add 2 electrons. So the mole ratio is there are 2 moles of electrons used to produce 1 mole of nickel. All right, and so at this point, if you calculated, you would have moles of nickel, but we need grams of nickel, so you need the molar mass of nickel, and that is 50, and you'll have your periodic table, so that is 58.69 grams in 1 mole of nickel. So now, just make sure all my units cancel. There we go. And doing the math, let's see how many grams of nickel we can make. Doing all that math, and I get that I can make 0.92 grams of nickel. And so here we go. There is the correct answer. And that is it for this quiz. The test is pretty evenly divided between Chapter 17 and Chapter 18. As far as electrolysis, I think there are 2 relatively straightforward multiple choice questions about electrolysis, and the rest of the questions are on voltaic cells. There are a total of 16 multiple choice questions. There are 2 free response, but I'm going to give you a choice. You're only supposed to do, you only can do one of the 2. I'm only going to grade the first one I come to, and then there's a bonus. So just a reminder, I will show up at 7:30 in the morning. If you want to get there early with me and start early, you're welcome to.